In this video, we are going to design our microservices with using the containers and orchestrators for the deployments. Before we start, we should ask ourselves what we have in our design toolbox and what we have learned so far. As you remember that in the last section, we have finished the microservice distributed caching with cache aside pattern. So here you can see the related patterns for the caching. But in this section, we have focused and learned microservices deployments with containers and orchestrators. So you can see the all related pattern and principles that we have learned during this section. So we have learned microservices, containers and orchestrators pattern and principles, which including the Docker and Kubernetes architecture with the Helm chart. And also we can see Kubernetes pattern, which are the sidecar and service mesh pattern. And also we can see DevOps and CI/CD pipelines. We can see deployment strategies, which are the blue, green, rolling, canary and A/B testing deployments. And we have learned infrastructure as code principle and practices into our architecture. So we can refactor our design as per our newly learning pattern and principles. Here you can see the final architecture design for our e-commerce application, which is applying the microservice deployments with containers and orchestrators. We basically select some main microservices, which are the catalog, shopping cart, discount and ordering. Also we can add here order fulfillment microservices like inventory, shipment, payment and so on. But the important part is, as you can see the image, this time we have deployed our microservices with using containers and orchestrators. So we basically apply all microservices, containers and orchestrator pattern and principles in this architecture. For example, for every microservices, we have containerized the application with using the Docker, and after that we will use container orchestrator for the Kubernetes to orchestrate these containers into our microservice architecture. And after that, when we are deploying the application, we are using the Helm charts to facilitate to deploying the application and reusable configuration files. And after that, we can use Kubernetes patterns. For example, sidecar and service mesh pattern. You can see that every microservices has sidecar container into the pod of the Kubernetes that can manage cross-cutting functions, for example, logging, monitoring, healthcare and so on. And also we will use DevOps and CI/CD pipelines when deploying applications more reliable and automated way. And after that we will use deployment strategies, which is the blue, green, rolling, canary deployments for our application to gradually deploy the application and see the potential impact of our production environment. And lastly, we will develop all these infrastructure with using the infrastructure as code tools, for example Terraform. So now let me explain one specific use case when developer push the code into the GitHub and after that trigger the CI/CD pipelines and what's happened during this process. Let me explain step by step. The first step is use containers for package and distribute microservices that makes them easy to deploy and run on different environments. That means once the developer push the code, we basically build and containerize the microservices for our application. In microservice architecture, containers need to orchestrate in order to manage lots of containers in your application cluster. So we also use orchestrators, automate the deployment, scaling and operational concerns of containerized workloads across cluster. So this provides to us setup automation. That means a container orchestrator can automate the deployment and management of our microservices, freeing up to focus on building and improving our application. So basically, in the previous image, you can see that we use Kubernetes and the pods that are container orchestrator for our microservices. So we use also Helm package for managing Kubernetes that make easier to manage and deploy applications using the Helm charts into the Kubernetes cluster, because Helm charts provides reusability that can be shared and reused across multiple clusters, making it easy to deploy the same application in the different environments. Think about that, the whole infrastructure could be on-premise and we can basically move this infrastructure to the Azure Kubernetes services, which is the managed Kubernetes, with using and providing the Helm charts. Also, we use the sidecar pattern in a design pattern, which a helper container alongside with a main container in a pod. Think about that this is a pod in Kubernetes and we have a sidecar pattern. The sidecar container performs cross-cutting tasks that are related to main container inside of our microservices. And we use service mesh pattern for managing the communication between microservices in a distributed system. It is designed to provide a uniform way to route traffic between microservices and handle the load balancing and monitoring the health of the system from the whole Kubernetes cluster. So service mesh pattern is also very useful when we are communicating the microservices and routing the traffic and managing the communication. And we provide the automation with the DevOps CI/CD pipeline, which is the series of the automated that are used to build, test and deploy software. You can see the CI/CD pipeline steps in here. We have a source code management step, and after that in the continuous integration part, triggers, which is the building and testing our application that containerize and make Docker containers image. After that, push the container registry these image, and this will be following the continuous deployment part with deploying and monitoring the application in the Kubernetes cluster. So we apply deployment strategies for microservices, which could be the blue-green, rolling updates and canary deployment to provide zero downtime to deployments for all microservices. And lastly, we can say that the whole infrastructure is using the infrastructure as code tools, which is the software development approach that treats infrastructure as a code base. See, we can use Terraform for infrastructure as code principles. As you can see that now we have implemented microservices with using containers and orchestrators. All these pattern and principles provide us set of benefits. For example, automation. Now orchestrators can automate the deployments for our microservices and provide scalability. Now our orchestrator can automatically scale our microservices up or down according to incoming demand from the client applications. And now our application is high availability because orchestrators can provide self-healing capabilities to ensure our microservices remain available even if one individual containers are failed. And now we are improved the resource utilization. We can optimize the resources as per the cluster requirements. Now the whole application infrastructure are portable because we use infrastructure as code, and now it is more security because our orchestrator also provides some security features, for example role-based access control and so on. So this is the design phase of our microservices using containers and orchestrators.